a series of lucky accidents, if you will. I never planned for it. But there was one thing that I was passionate about, and that is science.
Yeah.
Yeah. Ever since I was
how did you
school.
know that? Because I have a brother who's a surgeon.
Yes.
And from an early age, I could tell we had a book about the body, and he would sit and study that thing. Like I knew that he was going to do something in terms of medicine from a young age.
Yeah.
How did you know that?
Well, it's sort of similar to what your brother experienced, and that is the fact that every time I sort of see a scientific book or something that's scientific, I seem to get the urge to learn more about that particular topic, or even watching a butterfly, in the forest or something like that. It sort of invokes in me, it triggers me, and say, "Wow, why is that butterfly flying and so colorful and so on and so forth?" So I start asking questions.
Yeah.
Really, now that I realize, science is nothing except asking questions.
Yeah, absolutely.
Really.
Do you remember specifically like one thing that you remember being curious about as a kid and looking deeper into?
Okay, I'm going to go for it. Okay.
Okay.
So it's actually about, in biology, and that's where I was in a class. And the first thing I was asked to do is to go catch a frog. And I sort of said, why?
Yeah.
Well, the reason was I have to learn what's inside the frog.
Yeah.
So I had to do dissection.
Yeah.
I said, seriously? I have to go and do a dissection on a reptile? And the teacher said, yeah, that's how you learn, how does a frog function, what's inside a frog, and so on. And that was, my first reaction was really, I'm going to have to do that. I have to actually use a knife or a scalpel to open up an animal. But as soon as I did that and I look at the animal, it was really, again, sort of starting to ask questions.
Yeah.
Wow. So that was my first experience to say, maybe I am cut out for this kind of work and this discipline.
That's incredible. I do remember going through and doing the dissection of the frog. I remember my daughter just came home and she said at school, we just dissected a pig. And it's amazing that you have those types of opportunities and see the skills and the talents that you have innate in you.
Yeah.
Okay. So tell us, because I've heard the story about Pharmanex in the past.
Yes.
And from what I understand, you were working at a biotech company.
And
it was kind of like you were pulling in Eastern tradition and studying Eastern tradition to understand and validate it or disprove it even. Yeah. So validate, disprove, and then those things that were validated, looking at how we could incorporate it or commercialize it.
Yeah. So some of you, if not many of you who have been with Nu Skin for quite a number of years, would know that I actually originally started my scientific career, if you will, actually in the pharmaceutical industry. Yeah.
Yeah.
And that's what you were referring to, Bug, in the sense that when we are working for a pharmaceutical company, the first thing that we're asked to do is to what we call identify a molecular target, something, whether it's an enzyme we need to inhibit, or whether it's a receptor site on the cell surface that we would like to hit. And invariably, then the next question would be, if we have to intervene with that kind of approach, how do you do that? Because eventually it has to lead to a drug. That's what pharmaceutical companies do, is to develop drugs. So, and what happens is we're clueless. So where would we find such inhibitors or enzyme inhibitors and so on, and possible drug candidates? Well, we usually go to our so-called, every drug company has what they call a natural product library.
Yeah.
And typically as a scientist working in the drug industry, when I, and together with my colleagues, when we go to scientific conferences and medical and so on, it's usually in some kind of foreign land or exotic place. We are expected to bring back a natural product from that particular location.
Really?
Yes.
Wow.
Yeah, no matter what it is, whether it's a soil sample, whether it's a leaf or root or whatever, to contribute to expanding the natural library.
Wow.
That's why it's big. And over the years, obviously it's grown rich and big and many, many ingredients to look at. And that's where we start.
Yeah.
We take all those natural products there and start looking and to look for hits. But and I've been doing that, and I have been fairly successful in terms of developing drugs using that approach. But what I find is the fact that we never ever developed those natural products, the original natural product candidate.
Yeah.
Because it was for an economic reason.
Yeah.
And that is drug companies don't wish to spend and commit investment working on an ingredient that they can't patent.
That's natural.
It's natural. You can't patent that. So I say, forget it.
Well, there's no commercial value.
Yeah. So it's not coming from the business side of things. I say that's rather stupid because that natural ingredient actually constantly proves itself to be far safer than the eventual drug.
Yeah.
Because the chemical structure is passed on to my chemical colleagues, and they will start playing around and messing around with the molecule to come up with a patentable chemical.
Yeah.
That is eventually transformed to be a drug.
Yeah.
All right. But it has a lot of side effects.
Yeah.
And a lot of things that we have to learn because it's a brand new molecule. The body hasn't seen it. Nobody's ever knows about its profile and so on. So you spend years to prove it. And obviously, if you watch any drug commercial, you can see the guy who speaks at 10 sentences a second or whatever. And he describes all the side effects.
Yeah.
And yet he expects you to take that drug.
Yeah.
So and that's why I say, well, maybe there's an opportunity for me and my colleagues, and we started this company that we eventually called Pharmanex, based on natural products.
And what year was that?
That was back in 1995.
95.
Yeah.
And so your initial products that you took to the market, was it a big lineup of products, or there was one initial one, or?
Well, interesting that you should mention that, because the first one that we had was actually developed from a very traditional Chinese food ingredient. And it's called colistin. That was the eventual name of the drug. Not drug, sorry, of a natural supplement. And it came from a red yeast that most Asian chefs use in their cuisine.
So what is it? What's the value in cuisine? Is it like umami flavor? Or?
Okay, many of you would have seen roast duck hanging in Chinatown and so on restaurants. And if you look at it carefully, you would see that there's a reddish tint to it. Yeah, that reddish thing comes from the yeast.
Oh, I had no idea.
Yes, and it imparts a certain flavor to it, a unique flavor.
Okay.
Yeah. So, and that's what you mean. That's how roast duck are being prepared.
Wow.
Yeah. And then as we look further into it, there's another Chinese compendium on all these natural ingredients, and we discovered this particular ingredient was rather good for blood circulation. And again, right, I mentioned to you, scientists about asking a question. 500-600 years ago, when they described this, they have no clue what blood circulation means, except they know there's blood and you got to flow, right? So, but when we looked at it with modern science, we say, maybe it has something to do with cholesterol.
Yeah.
Cholesterol, the reason why cholesterol is not good in the blood vessels is the fact it blocks, right? So one thing led to another, and we said, okay, this is where we can marry our traditional Asian or whatever natural product history of use together with modern science and prove that it works.
Wow.
And we did all the classical, or what we call classical, traditional clinical studies and all. Eventually we got it published and in a medical journal, and it got quite well known, and that's where we started our conversation with Nu Skin.
Wow. So that was like the front running product.
Yes.
I imagine there were other products.
Oh yeah, we have 5 others that went out.
Remember, were they all focused on cardiovascular?
No. There was one for brain, one for immune system, one for muscle recovery, and so on. Yeah, we covered a whole slew of all kinds of different benefits that natural products can deliver.
Wow.
Yeah, that was back. We were in 28,000 stores, Buck.
That's incredible.
Traditional business, by the way. Yeah.
That's incredible. Okay, so let's talk a little bit about Nu Skin. I can't remember exactly what the comment is or the question. We'll get to the questions, you guys. I still have my own questions, and I get the prerogative. I get to ask the questions first, so we'll get to your questions. But Joe, when I came to Nu Skin, invariably you start to see like, this is from my perspective, and I'll give you my background.
Okay.
I wanted to be an artist. And I paint, I draw in the background. It's one of those things that I absolutely love.
Yes.
And coming here, one of the things that I noticed is that we talk about the colors of specific nutrients and the value that they have on the body. And so when I looked at like Life Pack, or when we look at G3, there are specific colors that are in there that drive benefits for the body.
Yeah.
And then when I looked at shortly after I came here, I think it was about a year after I'd been with Nu Skin, we rolled out Meta.
Yes.
And Meta was
purple.
Yeah. Correct me if I'm wrong, but it was 7 years of studying the color purple and blue and black and the value of those colors of naturally found in our environment on our body. And so is this just my perspective and I'm putting something on it, or have you and the team intentionally focused on color and the value of color within our diets?
Yes, Buck. Eventually we did. But at the very beginning, right, because we are scientists and for intents and purposes, we do experiments, right? And science, by the way, is a discipline that you just cannot talk. You just cannot sort of say, oh, this is great, and it's true. We have to do something. And the doing something is actually to conduct scientific experiments. That's really the essence of science, if you will. It's a very arduous kind of discipline because you have to do it. It takes time. Anyway, so the more we do experiments, the more we sort of play around with these natural ingredients, we find many of them are very colorful.
Yeah.
And obviously, it's always been rather strange to us at the very beginning. Why is it that these molecules, when we have it, right, when we look at it and we test it, it's always some color, whether it's orange, whether it's yellow, whether it's red, and so on, and they're colorful. Right. Then over time, that's when we say, most likely, these colorful ingredients are the ones that most likely are going to have the most, what we call bioactivity or health benefits. Yeah. And sure enough, when you look at the highest level, the government and everybody else now, the health agency and so on, they're now saying, the easiest way to adopt a great diet is to eat colorful vegetables.
Yeah.
They're all coming together. We are connecting. The color, this is an important point to remember too, right? About how we eventually got to PRISM, is the connection of something that is seemingly unrelated to its activity, but it is, because we know what the molecule is.
So this is a question for me, and I don't know which came first. This is a chicken and egg type of thing. Did our study of carotenoids and the yellows, the oranges, the reds, did that come before the S3 scanner? Or did Life Pack and did that come before the S3 scanner, or did the scanner come first?
Yeah, you're asking in a very sneaky way. Some competitive criticisms when we first had the scanner was, did you develop the scanner as a Life Pack detector? They were so biased. They think we were so biased that we actually had the scanner developed just to make our products look good.
People actually thought that.
Actually thought that. And
so that means we had Life Pack first.
Yeah, but if they actually had looked at the timeline of our product launches and the launch of the scanner, it was at least 15 years.
Oh my gosh.
After we have all these products, especially Life Pack, as many of you would be aware of, there we had it in the field for 15 years before you even thought about it.
So we were studying like carotenoids, antioxidants 15 years before we even found the technology for the S3 scanner.
Absolutely.
Wow.
Because I mean, we had back then technologies that we can actually look for these kinds of natural color ingredients and so on. But it was a very sophisticated and complicated method. We can't do it, right? We try to tell you, or we try to tell the consumer, wow, this is great. We've done the experiments and show you all the data. But at the end of the day, it's like, wow, that's pretty technical and difficult to understand. So that was the question we asked. Wow, we soon realized if that is that difficult, perhaps we should be looking for a technology that we can put into your hands, the consumer hand, to learn how powerful these products are.
Okay, somebody is asking, they said, this is interesting. What color do you see missing in most people's diets?
Oh, the most likely the wave, I think in terms of wavelength, guy. So look at the carotid is around 515. So it's between the blue and the purple.
Really?
Yeah.
That's the one that's missing the most.
It's around there.
Do you think it's because those vegetables, fruits and vegetables are less available, or that we're just naturally geared to eat the brighter colored stuff first?
Look at how we grow our vegetables.
Yeah.
We don't grow it the way that it should be grown. That's the problem.
Yeah.
Our dirt, the dirt, it grows in dirt, right? Vegetable is being depleted of nutrients.
Yeah.
That's where the plants are getting the nutrients from.
Yeah.
Is to soak it up from the dirt,
soil.
right? So if your dirt is poor and the dirt is sort of almost decimated and polluted and so on, what you're going to get is, although it looks like a vegetable, it looks like a good one you should be eating, and you should, but it's not going to contain the optimal levels of all these colorful ingredients.
It's so interesting that you bring that up, because I've read recently a couple of things, like the avocado that we eat that's in the grocery store. I believe it's called the Hess avocado.
Yeah.
And it's one avocado, but if you went back 50 years, you would have multiple different avocados. But to get the supply chain going, it's one avocado. The banana that we eat is one strain of the banana, and it's been genetically modified to be big and beautiful and the same, and that's what we eat, but it doesn't have the same nutrients. I was reading about apples. I've got a friend who has apple orchards down here just south of the company, and he sent me a video recently of a guy that has spent his career going back and finding lost variations of the apple and trying to bring them back. And there's all of these incredible apples. I went to his orchard this past year, and he had grown a couple of, one tasted like licorice. One tasted like, I mean, these are variants that have been lost, but they're starting to bring them back. But I imagine that's where we get the loss of some of these nutrients.
You're right next to the tree that it fell from.
Yeah.
Okay, the apples that we get in those grocery stores, that had been sitting in some cold storage warehouse or whatever for months sometimes.
Yeah.
Right? They were particularly grown in a way not to fall off from the tree when it's ripe. They were picked at a time, and they spray it to preserve its ripeness or to stop its ripeness so that it can be stored.
Yeah.
That's the challenge. In fact, sometimes I feel that the apple that I eat, sometimes it's just nothing but
mush.
Yeah, mush or just water.
Oh my gosh, Joe, I'm gonna have to go down to my buddy's farm and get you a box of apples, because from the tree, they are so amazing.
Absolutely.
They're incredible.
It's different.
Okay. So how do we take this and bridge this gap into where we are today? We've got the S3 scanner.
Yeah.
The S3 now, with all the technology and the advancements we've made, you and the team were very instrumental in working on the algorithms, the spectral ray technology that's allowed us to put it into this prism.
Yeah.
Can you tell us a little bit about some of that process of bringing that to life?
Well, I think it goes back to the question, to the comment that I just made, right? We have all the studies, and we have all whatever we've done to substantiate that all products are really safe and effective. Okay. But the challenge is, right, when we then launch the product and get it into the hands of our consumer, it's hard to articulate all that science, if you will. I'm going to lose people.
Yeah.
Right. I don't think they will truly, completely appreciate the power of these products.
Yeah.
Right. And therefore, we needed something or some technology that can help them to understand quickly whether the product is getting into the body. Because here's another myth in this particular industry, right? And this is always interesting to me. Yeah, this product is great, but they never talk about, no matter how great the product is, if it doesn't get absorbed and it doesn't get into your blood and finally to the tissues, it's not going to do you any good.
Right.
It really doesn't matter how powerful or potent your antioxidants are and so on. You know, that is really, in a way, pulling wool over your eyes, frankly.
Yeah.
You know? So, and therefore, and yet, yes, we have the data, but we we give you the proof, but it's difficult to understand the proof. And that started us to think, if we can somehow have a technology that you can have, and within a minute or so, you can measure and see whether the product works, it would be great. So that's how it came. In 2003, I think it was, we had the scanner. Yeah. And at that time, now this is an interesting transition here. And this is why science is so important and it's part of the Nu Skin ethos and a foundational cornerstone. Okay. And that is at that point in time, and we have many, many of our leaders, understanding at that time of the scanner, very exciting, that we were measuring antioxidants. We were measuring carotenoid antioxidant. That has been ingrained. That was the message we sent off together with when we launched the scanner.
Yeah.
All right. However, what I find, it's great, it's powerful, it's compelling, but yet there's still a level of technicality related to that term. And frankly, in what we do, it's sort of like, yeah, we have a technology that can measure antioxidants. What do you think a new person would respond would be? I'm willing to bet with you that the first response is, what is an antioxidant? You have to go through a scientific explanation before you can get that person's attention again. That's a fairly significant process.
Yeah.
Don't you think?
Oh, yeah.
Buck?
Yeah.
Yeah. But however, I mean, frankly, some of the leaders, it took me 20 years to get that antioxidant story over. And now they can do it and say, oh, yeah. And you're still married to that story, which is actually the wrong narrative with the PRISM now.
Yeah.
We have taken a great leap forward because over the last 20 years, we have done over 27 million scans. And you would ask, what's so big deal about those 27 million scans? This is around the world, by the way, Buck, not just the US and so on. Well, during that time, we also had gathered lifestyle choices or lifestyle profile of the individual who had been scanned.
Which included smoking,
what are you eating,
fruit and vegetable intake,
fruit are your intake,
exercise,
or your exercise,
sleep,
your BMI, your sleep, all these lifestyle things. We just were curious, and so we had this database.
Yeah.
So once again, science is about asking the right question and say, is there a connection? We couldn't do it. At that point in time, 27 million scans would take us forever to manually try to find statistically whether there's any relationship between those lifestyle factors and the scanner, the antioxidant number.
Yeah.
Until we got AI. That was the breakthrough that we had.
Yeah.
And then we dump all these 27 million data points and all that into our algorithm, our AI-driven algorithm, and it came out to say, that antioxidant that you were measuring actually means nutritional health.
Gosh, that's incredible.
That's the change, right? So now your so-called elevator speech or whatever you would like to call it, within a minute, you would say, we have a technology that can actually help you understand your nutritional health status better.
Yeah.
What would your response be? Tell me more.
Yeah, that makes sense.
Yeah.
Instead of going down the path of being able to explain carotenoids and antioxidants. I think it was 2 weeks ago when I was with Ryan, I looked up while he was talking and we found that I want to say it was 10, 12% of the population actually knows what an antioxidant or carotenoid is.
Absolutely.
But the other 90% are lost. And so this nutritional health core, it helps people understand, okay, this is what it is and what it does.
Right.
Okay.
I mean, that's your, what do you call it? Invitation or whatever. This is an invitation that everybody can appreciate and will actually respond in a positive way.
So tell me spectral ray. Somebody asked the question, what is spectral ray? How does that relate to all these 27 million scans in the AI? Because so is that the name of that process? Is it?
No.
Okay. Tell us what that is.
Well, we know white light, right? It's very easy. After a rainfall, especially here in Utah, immediately when the rain stops, there's still a lot of water particles hanging in the air, suspended. And when the sun comes and shines through it, it splits the light, right? And you get your rainbow.
Yeah.
Those are the colors that together makes white light. White light is not a single wavelength. Right. It's a blend of different wavelength colors. Right. So
Roy G. Biv.
Yeah.
Red, orange, yellow,
yeah,
green,
green
indigo,
yeah.
Blue, violet.
Yeah, you get Buck, you're much better than me. You can name them all in order.
Eighth grade science.
There you go. So you have it. So this spectra, this hyperspectral absorption, again, is a very technical term, but it's not a term that we have invented. It's been used in science. You pick up any, I don't know, we call it physical journal, scientific journals, and like physics journal, you will find people investigating hyperspectra like absorption. You know, so it's a common term, albeit rather technical, but it is a common physical technology that people uses. It has been used to measure. You know that little thing that you stick your finger in? The oximeter?
Yeah, the pulse oximeter.
Yeah. It hyperspectral absorption, guy. So yeah, that's a totally different, they're looking at totally different wavelength. So all we did was to use that principle or that concept, like concept, if you will, and put into the prism together with some photodiodes that can split it into 4 different wavelengths.
Okay, so the technology,
that's what it is.
The technology was there, it was out, but we had, because of the 27 million scans, we knew how this correlated with the relationship that it had with our nutrition and lifestyle.
Yes, we already know, by the way, Buck, right? From our previous scanner, can detect carotenoids on the skin. We knew that.
Yeah.
Right?
Yeah.
And I can go on and talk to you how carotenoid eventually, should be considered as a biomarker of all antioxidants. All right. Just like cholesterol is a biomarker of cardiovascular health, right? We now know it's quite well known in the scientific community because we are not just the only ones studying carotenoid. That is a biomarker of all antioxidants.
Yeah.
That's already been proven.
Yeah.
All right. So, and therefore, it's a great thing to focus on and to pick up on the skin. And you can pick it up with light. We already knew that.
Yeah.
Except now, that one, okay, I'll get technical a little bit. The previous scanner essentially uses light to shoot into the carotenoid molecule and energize it. Okay? And during that sort of atomic energy, if you will, it shoots back out. When it's energized a molecule, it shoots a signal out. And that signal is called the Raman signal. It's a very weak signal because it lives in a world of other signals as well. You need special instrumentation, or you need a special energy source to get it powerful so you can pick it up. That's very specific. Only the carotenoid will give you that signal.
Yeah.
No problem.
Yeah.
Right? But it was an expensive proposition to continue using that because of the energy required to drive that.
And that Raman spectroscopy is what drove the S3.
You got it. Up to the S3.
Yeah.
And that's when we started to think maybe an even more portable one, an even more robust one, and people can carry around and so on. We should be looking at different technology. That's how we went into this so-called hyperspectra. Now, the principle is very different. Remember, I told you, it's a signal shot out by the molecule. This one, with our hyperspectra, is about absorbing the light and refracting it back. It's almost like a special molecular mirror.
Yeah.
That's the difference.
Yeah.
Yeah.
From an artist perspective, what I've always learned is the color that we see is actually the colors that are the wavelengths that are being rejected from the medium.
Yep.
And what the everything else is being absorbed by that medium. We're just getting the colors that are being reflected off.
Yeah.
And so it's the measurement of that color that's being reflected off.
That's right.
wavelengths.
That's right.
Okay.
It changes.
So we've got a couple of questions. Someone's asking for some validations. Are carotenoids the only antioxidant stored in the skin long-term, acting like a built-in reserve to help fight oxidative stress from things like UV exposure or inflammation?
To the best of our knowledge right now, it is. Okay. I'm sure there's some antioxidants, but the carotenoids somehow, it's through natural evolution and so on and so forth. Remember, right? Our body adapts to the environment. And the skin, for example, is our most outermost living tissue. It's the largest organ of our body, but it stays on the outside. So it's constantly exposed to the sun. So over time, our body begins to sort of really adapt itself to protect it. Your skin is a very important protective layer. So they're starting to say, of all the antioxidants, fruits and vegetables. Remember, guys, right? The diet that we're eating right now only evolved less than 150 years ago.
Yeah.
Where it became, in general, 80% meat, 20% fruits and vegetables. Our genes, and we can talk about each longer than that, and it had evolved over 3 million years. Okay, and they have always been exposed until about early 1800 or so, industrialization. They were always been living in a world of 80% fruits and vegetables and 20% meat.
Wow.
That's why they're revolting.
So, do you want to tell us what you feel about the carnivore diet? I'm just kidding.
It's great, guys, but yeah,
no, but so fruits and vegetables, that was the protective barrier.
Absolutely. What do you do? And what do we pick from the fruits and vegetables diet that our genes have been living in? Well, I think the carotenoids is a good one because carotenoids in general is what we call fat soluble. It's not water soluble. Yeah. And underneath the skin and so on, there's a sort of a fat layer.
Yeah.
So get those guys up there.
So, but the prism, so there are other micronutrients that are in the skin.
Absolutely. Okay. Definitely. But so carotenoid is our biomarker because the other micronutrients that we have in the skin and so on, they're equally beneficial and so on. They have to get absorbed, right?
Yeah.
And in fact, the prism picks up, I already mentioned to you, the carotenoids. The carotenoids, in addition to showing the nutritional health data, it also is a biomarker of absorption of other non-carotenoid micronutrients.
Wow.
That's the power. That's the power. Nobody can do that. Remember that. All right. And some of you, I guess I'll pre-anticipate, if you will, that possible criticism. There are some other technologies out there that they say there's a veggie meter or whatever it is. Oh, we also measure antioxidant. What they don't have is that database I mentioned to you, about 27 million scans.
Yeah.
Without that, they can never translate what they have.
So incredible.
What you have in your hand is a powerful, powerful tool.
So grateful for all of those leaders across the globe that invested in the S3 and collected those 27 million scans since, what was it, 2003?
Yes, that was our first launch.
Okay, so somebody was asking, can we get a one-liner? This is the device which does X, Y, or Z, and kind of what you were saying is I'm thinking of this is your nutritional health score.
Yes.
As Ryan's talked about it, we are the company that now is creating a new biomarker. You might track, I'm wearing even a glucose monitor here.
Yeah. Oh,
because I like to see what's happening with my food and how my body's processing it based off of my exercise and my nutrition.
Yes.
But I'm tracking my glucose.
Yes.
But we might track HRV, your heart rate variability. You might track your sleep, your stress. You're tracking all of these different things, but nobody is tracking nutrition in this way.
You got it. And you obviously might actually ask this question. What's the big deal about tracking nutrition? All right. What's the value? And here it is. I came from the drug industry, as I mentioned to you, right? And drugs are very effective. I mean, in terms of treating particular diseases. But diseases in general are fairly localized. So what I'm saying is a drug can actually treat and cure a disease, if you will, but they can never heal the body. That's a very key differentiation. All right. The only way that you can heal after the disease has been treated or whatever the drug is the body itself. Huge difference. All right. And that healing process, if you will, or the nurturing of the body is actually through nutrition. If you can accept and you can appreciate that big difference, the big chasm between the two types of things, right? We're not treating drugs. We're not doing that, and so on. We're actually healing the body and nurturing the body, and that can only be achieved with nutrition. Then you can appreciate why we should measure it.
Yeah.
And this is the first time ever that you can measure it constantly.
That's incredible.
Within 15 seconds.
And you know, the amazing thing, I scan myself every day.
Yeah.
I scan myself every day because I want to see how things are fluctuating. And, you know, somebody talked about on here, I can't remember where it was in the comments, but they brought up, you know, if you go and get a sunburn, if you have a cold, if you, and I don't know if one night of poor sleep, how that impacts that oxidative defense, but all of these things can drain that. Can drain those antioxidants and those carotenoids. And I like to see if I'm seeing some of that over time, or if the stress that I'm under, how I'm managing that. But it gives me an indication every day of where I'm going, if I'm heading in the right direction or the wrong direction.
Well, the trend analysis on what you're doing, Buck, is way more informative than doing a snapshot.
Yeah.
You know, you dig at a snapshot. Yes, it's great on that particular point in time. But now if you do a trend line, you're starting to look at how you're living your life. That's the key. You know, there are certain changes that you might have installed in your life that you don't remember or you ignore.
Yeah.
And say, okay.
So here's a question for you, because these antioxidants, the carotenoid is stored in that fat layer.
Yeah.
So let's just say that I start eating brightly colored fruits and vegetables, or I get on Life Pack. How much time will it take for that to actually manifest in my that fat layer?
Typically, you will start seeing an improvement. I would say on a conservative side, definitely after a month. And in fact, many folks will start seeing it actually as soon as 2 weeks after consumption.
Oh, really? 2 weeks?
Yeah. Just to add to what the bugs say, yes, it's in the fat layer, but it's also not just the layer. It's at the carotenoid. The carotenoids are also on the actual skin layer too, the non-fat layer as well.
Okay.
Yeah, it's sort of evenly distributed.
That's great.
Yeah.
So somebody says, can we really see any improvement if we measure daily? Is it better to do it once a week or every 2 weeks? Well, I don't want to.
Yeah.
I think it's fun to look at it every day. And one, it helps me understand how's my prism. I'm looking at it to just see, am I on track on a regular basis? Am I up? Am I down? But it's interesting to me to understand, is a poor week of sleep, does that translate this week, or does it translate next week? Or how does that all come together?
Well, that's the thing. And you can only do that if you measure every day, because then it forces you psychologically, if anything else, to start looking if there is a difference in the score, okay? That you're going to start looking and say, what are the differences between the days or so on? If there aren't any, and really sometimes the variation or the change the difference is not that big, then you carry on and you start looking, right? If it's trending down, I think you should ask the next question and say, really, over the next couple of weeks, what did I do? Apart from eating, there are other factors that will affect the antioxidant or the PRISM score as well. So it forces you to examine your life a bit more. That's what monitoring is all about.
Yeah.
Isn't it? Yeah, to help you understand. You're not supposed to be able to, frankly, Buck, if you do it just one time, and it's sort of okay. I don't know when you've taken your reading, whether it's in the morning, immediately after you wake up, or after you pee, or whatever, right? Yeah. So always, if to the extent possible, that's why one of the reasons why we made it so portable, to make it user friendly.
Yeah.
So there's way more value to measure it.
So okay. Which I completely believe in. That if we do not track something, then you can't change it. If you don't know where you're at, you can't make any improvement.
Yeah.
And what I find is that as I am using the Prism and I'm seeing where my score is and where I'm at, I'm constantly wanting to get better on that. And so it impacts the choices that I make on a daily basis. Yeah. So, for example, we had a book release party yesterday.
Yes.
And we went down there, and there was fruits and vegetables, crudita.
Yeah.
And usually when I see that spread of crudita, I just pass over it. But now, because I know of how important fruits and vegetables are, I filled my plate up.
Yeah.
Because and then had a little bit of the sandwich that was there and everything. But I find myself choosing salads, which isn't my first choice, or the fruits and vegetables to try to get those antioxidants first.
Yeah.
And I think that's the biggest thing that we find is that behavioral change takes tracking. And when you track, that's when you make the changes required to actually put you on a path to health.
Yeah. It's clear. I mean, to sum up quickly for you.
Yeah.
Right. In my perspective, all of us are overfed, undernourished. Okay. And these two things, once again, you got to think about it. All right. So what do you say that? Overfed is due to all the calories that you take in, whether in the form of protein, lipids, carbohydrates, and so on and so forth. That's related to calorie-containing ingredient.
Yeah.
Undernourished, the nourishment that you actually get, I'm actually referring to the micronutrients, the vitamins, the minerals, the botanicals, the phytochemicals, right, that we have in our products and so on. Those ingredients have 0 calories. You can never get fat on those. Okay? But we don't pay as much attention to that. And because what is the signal that you get when you start eating? When you get hungry. That's why we eat. Okay? All right? And then when we get stress or whatever, there's what I call stress induced eating as well. All right? That is another signal. You go and look for things that taste good. They are all macronutrients. And that, right? Isn't it, Bug?
Yeah.
So, and that's what we're trying to address here with the PRISM. Now you have something that you can see that can encourage you to pay a bit more attention to those things that will nourish your body.
Yeah. That's great. And I think that's exact. In fact, we've got studies that prove that this is one of the best tools to change behavior. I think it was a study out of Yale.
Oh, absolutely. Yeah. Okay, this is not something that we invented to be just making life back look good. Okay, guys, we got that out of the way, okay? You can answer that. If somebody else from another company repeats that, we can shoot him, but I think it's better to shoot him with scientific data. Anyway, so the question then becomes, right, the Yale study actually was very interesting. Using the same technology or the same kind of scanning, because they wanted something to find out the nutritional status of health in the inner city kids. Okay? And the Yale professor was rather reticent to send all his graduate students or whatever, or her graduate students out into the field to do this, to conduct this survey with invasive technology, to take blood.
Yeah.
That's a little bit dicey. You're never quite sure, right?
Right.
And not all of them are trained as phlebotomists or experts in taking blood. So it's a little bit dicey. So she told them, no, we're going to use this non-invasive, fairly quick technology called the biophotonic scanner. And we will use that to measure everybody. All right. And then ask them the corresponding question.
Yeah.
What are you eating?
Yeah.
You know, and sort of how do you exercise? And, you know, what sort of your diets are you eating and so on. That is how useful it is in a sense. It's an independent, you know, now validated, if you will, by several universities. I believe you heard from Steve Hatchett that we are in the process of conducting 6 additional studies in several universities, including Stanford, around the world, and to address some other questions that come up.
Wow.
Yep.
So you guys stay tuned on the science because we've got more that's going to be coming. So we've got roughly 10 minutes left.
Yeah.
We can go longer if you want. This has been fun.
Okay.
But, we have not a new book. It's a new release, a new edition of your book, The Aging Myth. And there are, is it 4 more chapters?
About that, yeah.
Okay.
Yeah.
I haven't actually gotten my own copy yet.
Well, hard copy is not available.
It's not available yet. Okay.
So ebook is.
Okay, ebook's available, but here's the question is, can we give a little bit of a sneak preview of why we included these new chapters and what's in them?
Okay. So I'll briefly summarize the original intent of the book, right? And that was written during the our period or era that we call age lock, when we started to understand fundamental sources of aging in the body. Remember, Nu Skin, when you talk about what is Nu Skin all about, we're an anti-aging company. And we can talk about that. Anti-aging is synonymous with youth preservation. So there's another topic we can talk about. It's the same thing. Anyway, so, and we wanted to do more than just symptomatic relief, if you will, cosmetic coverage of aging symptoms. So we went looking for the sources of aging. We found them at the genetic level. And collectively, all the genes, they found about 23,000 of them. We found that different clusters are responsible for different different aging in different tissues.
Wow.
Right. So we call them the youth gene clusters. Okay. And it's very powerful discovery that we found, and we started to develop our products based on that. But again, it's genetic science. It was once again one of those things I had to explain. And it was difficult. And I said, well, maybe a book can help. Because it was really the book. I'm hoping it's written in a sort of a layman's language that should be easily understood. I'm hoping it does. So we talk about all this gene expression and so on and so forth. And then a few years back, with the advent of AI and with all the other products we had, like Colorful Purple, Meta, and New Biome, and all these other products, I'm starting to say, well, actually, there is another evolution in science that I need to include, to help all our leaders to understand why we are doing all these products and how unique they are and so on. So I said, but how would I do it? I'm going to update this book. How would I do it? It's actually a bridge. So genetic science, when you talk about gene expression, again, it's almost like talking about antioxidants, and it's a bit difficult to understand what that means to an average person.
Right.
What does it mean if my gene expression profile changes? So now what I've done in the part 2, I call it, of the book, of this new book, is a translation of that gene expression to something functional that you can understand.
Okay. So let me kind of give an example. So my grandfather, he died from complications of Alzheimer's.
Yes.
My mother passed away this past year, complications of dementia and Alzheimer's. And I've gone through taking a DNA test that says that I've got these genes that could lead to dementia and Alzheimer's. But whether those genes express is determined partially on my lifestyle choices, my nutrition, and the way that I'm living.
So that's where Buck just highlighted one of the most difficult point to understand what we do with HLOC and what mutation does to genes. Okay. A mutation is a physical change or a physical defect actually on that particular gene. There's nothing HLOC can do about that. All right. It's going to, from the get-go, since you're born with that defective gene, right? You're going to express a particular protein because that's all genes do, is to make protein. It's going to be a different one. I can't influence that. All right. You have to literally physically repair that gene, and that's what gene therapy is all about, and so on, the other type of approaches. For us, we are just focusing on healthy genes. Okay. And the challenge is that these healthy genes get dirty over our lifespan. Because of our lifestyle. They get covered up, they get dirty. So they don't express themselves.
And so the lifestyle that we're engaged in, it helps those healthy genes express the way that they're supposed to express.
We're cleaning them out with our products, with our HLOC products, if you will. We are restoring them or resetting them back to a more youthful state. That's clean. That's the difference, that we can influence. So, and that's the translation. I say it's not easy, right? But nonetheless, it's a powerful enough technology. So look upon it. So we got all this set up, HLOC and so on. Nu Skin is a company. We continue to develop and improve evolve our science, if you will. And each evolution is dependent on the previous one. We couldn't have done this. We couldn't have done the PRISM if we didn't have HLOC. You know,
that's incredible. I mean, when you think about it, I've often thought, I mean, I've talked with Jeff about this, about, you know, I would love to go back and look at Raman. I can't remember his full name, but understand what led to him actually develop that technology that measured the difference, the distance of stars, the Raman spectroscopy. Like, how did he come to that? And then we get that information, and we've been studying brightly colored, you know, antioxidants and carotenoids for years. And then we go in and we're studying, you know, meta, and spent 7 years studying purples and blues and blacks and the impact that it has on the body. And now we have this device that will measure these, you know, and make it available for everyone based off of the new technologies that we have.
Yeah, it's key. And that's why, you know, it's important for us to sort of appreciate the PRISM. It's not your mother's biophotonic scanner anymore. Okay, it has transformed.
Yeah.
You know, insofar as, I'll give you an analogy. If maybe you appreciate it, maybe you won't, I don't know. It's the Rosetta Stone. I'm assuming there's a Londoner here. You should know what the Rosetta Stone is, because it's one of the most powerful exhibits they have in the British Museum.
Yeah.
It was discovered back in 1850, thereabout, by Napoleon when he went and took over Egypt. On the Rosetta Stone, you look carefully, the reason why it's so fundamentally important, because it had inscribed on it 3 separate languages. The hieroglyphics, then there was a demotic language, which is an ancient language, and then finally Greek that scholars can read. All right? Until the discovery of this stone, nobody was able to understand what those hieroglyphics are. They thought they were comical cartoons that the Egyptians loved to draw on the pyramids. Nothing less, nothing more.
Not a language.
Yeah, not a language. Nobody could read it until this Rosetta Stone was discovered. And then they knew it was a language. And that's how we are now really be able to understand how the Egyptians lived 5,000 years ago. All right. It's the same here. All right. The PRISM is our Rosetta Stone of nutrition. We have translated it now. We're giving you in your hand a tool, right? Whatever it is, to help people to really sort of fundamentally look at their lives on numbers. Remember, all of us were graded by numbers ever since we were born. When you were born, right? Your OBGYN guy took you up by your legs and smacked your bottom and gave you an APGAR score. Bucks, you know, here's some kids, right? 9, go home. 2 or 3, stay in the incubator for a couple of weeks until you get better and your APGAR score. Went to school, you know, and our parents say, oh, you go to school. Well, you get educated. Well, yes. What? To put data into your brain. It's the same with AI, all right? Yeah.
But the trend is what
trend is what's really important.
And so that's the reason that you should be scanning on a regular basis.
Yeah, you should be.
And why every home needs a PRISM.
Yeah. Well,
and family members need to be scanning.
Absolutely.
Okay. You guys, really appreciate all of the activity today, all the questions, all the comments that are coming in. We're going to take all of these and see if there's a way that we can get back to you guys afterwards and answer some of these questions and get to you. But you guys, I really appreciate you joining us today. Big thanks to Dr. Joe Chang.
Thank you.
Thank you so much for all of the years of research and the depth and the direction and the team that you've built that is like leading the science that we have here at Nu Skin that is helping us make lives better all across the globe. And for all of you guys that tuned in, this is Integrated Wellness, the Integrated Wellness Revolution. Make sure that you're tuning in every single week. Make sure that you're posting this, post the Zoom link. Let's get as many people on here as we possibly can, because at Nu Skin, it is our mission to help 10 million healthy households understand what we do. And the only way that we're going to be doing that is if we're sharing this information all across the globe. So you guys, thank you so much. Live the mission out loud. Be a force for good. My name is Buck McMurray. This is Integrated Wellness Revolution. Thanks again for joining us. Have an amazing week.
Yep. Bye, everyone.
Bye-bye.
Nice to